So welcome all. So now what last session we had gone through the ALS, alternating least squares, which is called collaborative filtering. So to give a brief, what this is you have set of users and you have set of items. Now each user is taking up these four items. Okay, out of these four users, these four items have been bought, and you want to know which is the item this particular user is going to buy out of these four. That is the whole idea about this least square algorithm. So what it is going to do is map the users, map the items, and then based on those mapping, come up with predictions and recommendations. So this is basically a simple program that's already there in the web. I've just taken it from the Spark example. So I'll just give you the example also. So if you see here, this is uh, the collaborative filtering is the name of the algorithm. It is there in Spark or Docs latest, and the example is here, ALS example.java. So if you take up this thing and put it in your what do you call browser and say like this, it will just take you. It will just come up with the GitHub example here. So if you see here, this is the example which I just copied, and here in this particular class itself, he has created this rating object. Okay, this is a class that is created by, within the class.
Prakash, can you please zoom it a little bit more?
Okay.
Yep, sure.
Okay. So yeah, if you see this one, this is the class that he has implemented. So the most important thing you have to remember in Spark is serializable. Why is this serializable very important? Because it enables the object to be moved in a wire. Okay, so what is wire? Wire means in a particular system, if there are two processes and two other processes here, so you want an object from this process to go into this process, then you need serialization. So both of them are running in different JVMs or one JVM. Still, if the object has to go from one process to another process, you need serializable. If it's running in different JVMs also, this is going to help. That's the big mantra of distributed computing, that you want an object running in one JVM to go into another JVM, then you need the serializable in Java. This is basically saying that, okay, user ID, movie ID, rating, timestamp, and then there is a static method, parse rating. So what he has done is he has just taken the Java RDD, and this is a new style of calling the method. So a static method can be called with two two commas. What do we call this? Comma? No.
Two columns.
Columns. Yeah. So this is how it is called. This is how the sparse rating is called, which is there in this. So to make this much more easy, I have there are many ways of reading a text file. Okay, so not all ways are going to work properly. So there are some, if you run this example as is, it won't work. Okay, because depending on the number of depending upon your Spark engine, few of the methods are there and few of the methods are not there. So my particular Spark engine, I've used 2.1.1, So it's not the latest ones. And I have shown different ways of doing things. So what I have done is to make it more object oriented. What I did is I put the ratings in another class by itself. Okay, this is serializable, same, no big thing. But instead of making it a static, I just made it a normal Java bean, so that I mean there is no big reason. It's just a simple Java bean which has its own containability within itself. It's not, you can use it as a simple bean. Okay, so having said that, there are multiple. I told you there are multiple ways of reading a Java file. Now here you see I put the AL. Where did I get this ALS? Okay, so again I went back to. You can go back to. Okay, yeah, these are all the ways. I'll browse through them a little bit later. So this is the data, which is again we just do a simple Google. It's already there here, but yeah, let me do like this. Yeah. So this is all the data that we have. So to give a brief about what this data is, this is user ID, and this is the movie ID, and this is the rating that is given, and this is the timestamp, right? So you have 0 as a user ID, 1 as user ID, 2 as user ID. Like this, the user IDs are changing, and these are the movie IDs that are there. 2, 3, 5, 9, 11, 12, 19, all those things are movie IDs. So you see here, their movie IDs are getting repeated. Okay. The rating is from 1 to 5. So 3, 1, 2, 4, between that, it will happen. And why we need this timestamp is because when the user has bought it, so based on that, the recommendation is going to happen. So we have in our, if you look into this one, the code itself, a Spark session is built and it is given a name and then said get or create. Okay. What I have done is I just did more of little bit more object orientation and then put that in Spark parent. So because any other code that you want to write, any other algorithm you want to implement, you just can use the Spark parent and be as easy as possible to make it more easy. So in our thing, we have this, if you guys don't know about log4j, log4j has two simple ways of, you don't need a big log4j.xml. You could just use this configure and it will configure the console as a root logger. You can also have a rolling file appender in this, and you can give a uh, path for it. And if you just don't want, there are a number of layouts that you can use. Okay, so let me do a simple thing. So these are all the layouts that you can use for log4j JSON. It's a Hadoop layout. All other things are Apache layout. For just uh, to just understand that, okay, we can use different layouts. I have used log4json layout. So the layout will happen. The messages will come like this. It's like a log. Okay, if you are using Notepad++, you can use the plugins and then convert the text into a simple JSON. So let me close this. Okay, and let's start. All right. Yeah, having said that, now we have this log4 JSON, and it is in this log. So here you see I have used this twice because this is for console appender. So some anything that you want to be shown in the console, you can put it like this. But in usual production, what do we have is we have a location where we want all the logs to be there. And most of our logs, if you want to put that into Logstash or a Mongo or Elasticsearch, a JSON will be very helpful. So therefore, I use this. We can just directly use the log4j JSON and put it into MongoDB and then have Elasticsearch look at it. So or Logstash to look at it. And this particular thing is the root logger. Root logger is basically the main log that you have. So, and then we are using this guy, perform ALS. So our we have
Prakash garu, is this code in GitHub also, or it is only
I'll
your
put that in
personal?
GitHub. I'll put this in
Yeah,
GitHub.
please.
Okay.
Okay.
So these are different ways in which you can actually read a text file. So what we are I also moved this out just so that this is there only for our testing purposes. Okay. And then in this perform ALS, this is where we are actually doing it. So if you see here, we are not using Kubernetes, we are not using any sort of simple Java code. And how do we include this part? There are two ways, many ways, of course. So this Spark, I have used Maven to include this part. So if we go to the, where is this Maven? This is there in GitHub also. Okay. This is our dependencies. If you see here, we have PDF and we have some MongoDB. So all those things are not required. Okay. You just need the mlib and you need Spark SQL and Spark core. You see here, the library is exactly same. So in our dependency, we have to make sure that the libraries that we are using are exactly workable with each other. So just because you take the latest from core doesn't mean that your other things will work. Okay. So if you don't have 3.1 mlib, then go for the previous version. So that apart, now we'll go back to our simple program that we have. So it is just taking the Spark. Let's look at the Spark parent, what this is doing. So it is giving a Hadoop directory where we are putting our Hadoop. So WinUtils, what is this WinUtils? Okay. WinUtils enables the Spark windows to serve as a Hadoop shell. Therefore, if we put this in the home Hadoop home directory as this thing, then it will take WinUtils from that. So let us.
So for the MacBook, we don't need that, right? It is by default.
No, we need it.
Still...
MacBook, yeah. For MacBook, it's already having Debian base, so we don't need, yeah. So if you look into this one, you see here. The or win Hadoop bin. Okay, you say DNR. We have it here also. So let's use this guy. Oh, don't have it here.
Hadoop, I don't think you should keep bin also in the path, right?
No, this one doesn't have. I accidentally removed WinUtils. Yeah, I
Oh,
removed WinUtils because I wanted to show what the errors will get.
oh, I see.
So let me do that. So we said Hadoop home directory is in the bin directory. Is this guy? Yeah, is here. So it should go to home dir and slash bin and see if there is a Hadoop WinUtils. Why do we need WinUtils? To simulate the Hadoop environment. So Spark, excuse me, sits on Hadoop, and it is having the. I mean, it's a very big thing. I'm just trying to put that into two sentences. So the Spark is going to have these RDDs that are different that are used by different processes. So each of them will have a different partition, and the process is working on that, and that's a stage is happening. So I'll show what those stages are and how to go with this. So what we are having is our driver memory. Driver is our main class where we are invoking the main. That's the driver. So driver need not have a lot of memory. It's just calling the executor. So we are creating the executor memory here. We can just make it 8G or 5G or whatever. And these are the number of partitions that an RDD or a dataset can use as a default. So the master is one, which is driving the whole thing. Okay. So the master, Spark is basically master and slave. Okay. So when we say it as local here, it means it is using the local system. In Cloudera and other places, we'll use Yarn. Okay. And then Yarn becomes the master, and it is able to manage the drivers and all those things. So if we have to use, there is this guy is basically an NLP that is included in Spark, but we are not using that one. So I just um, done this and just do a get or create. So the big thing that we have changed is basically we have changed the name, and we have created some configuration environment that is helpful for fast processing and to be able to understand. So if you see here, we are by default we are setting this 50. Okay, this uses the hardware. Now let's see what we are going to do. Okay, so in perform ALS, if you see here, okay, so let me do a simple debug. You see this guy. Okay, illegal access is one. I'll talk about that. So Spark takes in Hadoop environment and Hadoop security things. So therefore, it says, okay, this is what you are doing in get session. This is what is happening in get session. Oh, we are not going up. So in our, let's see here. So by default, JSON is JSON log will look like this. So if you see, it will give the message and the value. Okay, this is the metadata: name, time, date, level, thread, and all those. So we can change the level by just doing get logger dot set level. Okay, this is helpful in our directly. If you take this directly and put it into Mongo will create a table collection out of that, and you can just hand over the connectivity from Mongo to Elastic, and then you can search in Elastic anything you want. Like for example, Microsoft, it will give you all the messages where Microsoft is there. They're pretty handful instead of just normal log. So since we are not able to go to the first one, so let me restart it, but with a different combination. Let me do this. These are very important, therefore I am going through each one of them. If you try to just run the
I agree, Prakash. Yeah.
code like as is, you won't be able to do it. So in the arguments, you have this illegal access permit. So this illegal access permit is required because if you take a look at the data, I put our ALS data here. So if you just check it out, see 0, 2, 3, 4, all of these, whatever is there in that data, I just copied into Notepad and I put it in the local data. So if you see here in the properties, this read only is given. Okay, so when there is read only, the Spark comes out and says I don't have access to it, and you get error. Let me run that. Okay, first let me do this. So of course you have JDK 16 dependence. These are Maven dependencies that are coming in. In the common, you can set the output file as d log dot log, and then you can just, this is our console appender. Okay, so you can use that. And the other thing I wanted to do was yeah, let me apply this, close it. In the console properties, we can set the value of how many lines are there. Okay, so since we put that in the file, we can just open that file. So let me do this right now. From ALS. Okay, just for our understanding, what is this doing, you know? Okay, so you got the session here, and how do we know what are all the sessions and how these things are happening is we can go to this guy.
I think it is still in the debug.
Yeah,
it's stuck at the debug only.
No, it is at the breakpoint.
Oh yeah, it already started. Huh? Okay, super.
So this is the executor, and you know, executor driver added, and these are all the jobs that are there. No other jobs have been created. And if you look at the stages, there are no stages, no jobs are there. And this is our environment. This is our path. Okay, and this is the JDK version. So you need not have 16, you can have just 8 also. So it has created a master, and it is showing the executors that are there. Okay, so over a period of time, we should be seeing a lot of other things that will happen here. Okay, event timeline.
Yeah, once you start processing it, you see the other things, right? These are just the init things, just the starting things.
So our get session, this guy has created all these things. So if you look into the console, you would see that, okay, let's open console. Yeah. Open the console. Where is this? It should be there in the console.log, where there is console.log, and then see source, environment. ALS.log. ALS.log. We have used the same thing. Okay. This guy. This guy is highlighted up. So if you see here, illegal access is deprecated and will be removed in near future. Okay. So why we had to use this is because of that read-only thing. If I don't use this, then it won't be able to read the things properly. We have not gone into that read-only mode till now. So therefore, you don't see any errors here. But once we start reading the particular file, you will get the. So here, let us see Hadoop.
Why is blood red color, man?
Yeah.
Because of illegal access or?
No. It is a notepad setting. Somehow there is some setting here.
Oh, I see.
That was the problem. So there is a setting issue which we can do. It's nothing to do with the.
Gotcha. Yeah. Not to do with the execution, right, of the program.
No.
It is a notepad plus. Okay.
Fine. So let's say find all in the current document. This is much better. See here, Hadoop. Everything is this. As soon as the Spark session is started, the Hadoop is created, and it is sitting over that Hadoop. And you would see that the Hadoop is not found. It looks at the Kerberos util, and Kerberos is basically user authentication authorization services. Okay, so everything is Hadoop here, Hadoop security. What is the user principal? This local user principal, all those things are authorization and authentication. The security group is taken directly from JNDA, which is embedded into that Windows. Okay, so since I am the admin, I am the user, it is taking all these directly from the Windows credentials.
I see.
I'm not supplying anything. In normal production environment, you would be supplying all these groups. Okay. So that apart, now let's go back to our thing. This is what is the session doing.
Yeah, let us go to the, I think it should throw error, right? Because you have removed the illegal access.
Did I didn't remove it.
Oh, really?
I thought we can remove it later on.
Okay, it's still there. Okay, so it should.
It should be able to read it.
It should be able to read it. Yep. I think we will execute this on our local as a homework for next week session, so that we'll have more clarity on this, right, while running it.
Yeah, if you start implementing it, then you will see the differences, because these things are, like one line. Okay, I mean, if you read it, it doesn't tell you anything.
Yeah.
If you don't understand what is going behind it, then when you get into any, I mean, the code as is won't work. They have used it for Kubernetes and other container-based systems. So as is, if you copy and paste, it won't work. That's why I'm trying to go through each one of them. So here you see this, you're reading the data from the ALS.txt. We have that, I've shown you that. It's taking it from here. The Spark is the Spark session, and you're reading a text file. So, excuse me. There are many ways to read a file. Okay. If you see here, this is saying that it is a Spark stock prices. This is the one that we gave in our configuration. So what are different ways of reading a text file is there in here. So let me put that. So these are the different ways. In the text files, you can just give a path, or you can talk about, say, for example, this is coming as a comma separated, line separated, or these things. Then carriage returns and line separated ones. Then you can do this. Okay, and CSV files you can just take. So this is Scala. This is Java. This one is Java. So what Spark here is Spark session. Okay. It can be Spark you can have Spark context also, but nowadays everybody is using only Spark session. There is no Spark context. It has been deprecated. And this will give you a different ways of reading a file, how the files are read. And it is very, very, very specific. Okay. So for example, if I try to read it in some other way, I've just given you this kind of this is another way of reading it. Okay, so here what we have done is we have taken, let me go through this one. So this rating, we are just creating this object. In map, what you're doing is map. What is map? Map is basically telling us that we are converting one object to another object. So you have map and you have flat map. In flat map, what happens is you're taking one input and you're creating either 0 or many outputs. So it could be 0, 1, 2, 3. With one input, you're creating 0 or more outputs. That's called flat map. And map is basically you're taking one input. And what is that input? It's a simple string that is coming from here. And you are creating an object of this type. Here you see it's a simple Java, and I put that in this one because it creates more easy to read. There is another way of doing it, like this guy, where you are reading and you're creating a map function with row and rating. So this is directly creating a data set, whereas this is creating a Java RDD because we wanted it as RDD. And then we got this. Okay, so let us move forward. So even in our example, they have used yeah, as RDD, Java RDD. See this guy? And then call the map rating. So instead of parse rating like this, calling a static variable, what I have done is to make it more easy, you are instantiating the rating object and you're passing the string into this parse rating and you're returning back this rating object. That's what is happening here. That is what is happening here. It is calling in the rating, it's calling the static object, which is creating this object and returning this back. What I meant, why I meant is like you can have a simple object. You don't have to have a static method in all the objects to give it back. Okay. So let's move forward. You see here, this has created still, this is lazy loading. Okay, you don't see anything with this stock rows, right? Nothing. You don't see anything. You don't see any data. Even if you take the RDD or class, nothing. This is called lazy loading. All the Spark objects get loaded once the actions are being called on them. So what is an action on stock rows is basically the show. When you call the show or collect, all those things. So here in our expressions, I have put something. See, ratings.collect, if I say, then it will show the data. So this is another way of taking the data, like I said, which is directly creating the data set. So instead of doing this. So by the way, this way of creating a class, this is called anonymous classes. These anonymous classes are there right from Java 0. Okay. So if you do any button.add action listener, if you go into that one, then you see that anonymous.
That's in Java Swing or Java Applet, right? Is when you use those anonymous classes.
Yeah, it is there from 1.0. So what they did is the whole thing, they just said you can use Lambda. So the Lambdas were there. Lambda is not a new concept. It was there from long time, but we didn't use it quite extensively in our day-to-day stuff, except in multi-threading or AWT, new component generations. You wouldn't have gone through these things. Okay, you see here, what we are doing is we have got the Spark session. We are converting the Java RDD into dataset. Why do we need a dataset instead of RDD is a big question. This data RDD is using a simple object with a user-defined class. A data set, you can use selects. You can use it like a table. It gives what are all the columns that are there. So once we go through each one of, once I do a show, you will see here.
Show is where actually to start processing, right? Lazy loading.
Yeah.
Till that time it waits.
Yes. Yes. Now you see here, this is the movie ID. It is only going to show the top 20. Okay. So this ratings.collect is going to collect everything from the data. So usually we don't use this ratings.collect for anything. Okay, because if you see here, it takes all of the data and your memory will die. So never use ratings.collect in your system. Okay, it is loading all of the data and giving them as a list. It is an action. So to make our RDDs initiated, don't use collect. Use a show or take or something where you are only looking at a very small patch of data. And this is only after actions are being performed, the data is manipulated, data is worked upon. This will help in lineage of the data. So that's why we are doing it. Now we have all the data that we need from our ALS.txt. So what we do is we do a random split. So we split it across. This is again telling you that, okay, 80% of my data, I want it in splits of 0. And 10% of my data, which is disjoint, okay, they don't intersect, are in my test. And 10% is in my runtime. So why do we need this is important. Why? Because we are training the model with a huge amount of data. And then after the model is trained, we are trying to see the hypothesis, how much is it working, how much is it closer to the existing data. And then this is our unknown data, that is production data. So we are not using the data that's here in any of the training, and we are not using data that is here in any of the training. This is for this we don't use at all. Actually, in our program we don't use this. We are only mostly using these two. This is like production data that we want to use the model against. Okay, now this is ALS. Now in ALS you have the users, the items, and the ratings. This is exactly how the algorithm is. You would have the user ID, and you would have the items, and you would have the ratings. Therefore you have this user column, item column, rating column. You can give whatever name you want inside of it, but these are the three columns that are must. So if you look into this ALS, I'll just open this ALS. Okay, this is all written in Scala. Okay. So what are the important things in the ALS? You have this model, ALS model, and ALS algorithm that is there. So where is our Pearson's model coming into picture is in yeah. This is the guy. Okay. We are taking all the ratings, we are doing a cross join, and we are getting the predictions. So all those things are already done for you. I'm just trying to, this is part of the Spark source code. Okay, so you don't have to know everything in this, just have to know how it is done. So you see this max iteration is going to tell you about how many times, say if your hypothesis is saying that the value is this much. and once you implement the model and your result is saying this much. So there is a difference between these two. So in order to reduce the difference, what we do is we come up with more iterations. This is what it is. If you look into this one. There is iterations, item column. You have this user column, you have this item column, and iterations. So go through this thing. What this is telling you is what are all the iterations that are happening, and hey, this is what is being done. So the theory that we have gone through yesterday is all written here, and collaborative filtering, implicit feedback data set. What are all the collaborative, the PDF that I presented before is here. So let me just do this. Okay, collaborative filtering for implicit feedback tests. If you have IEEE thing, then you can go through this and how it is actually implemented. So the BLAS that is implementing it, how it is actually doing it is there here. Okay, this has been there from long time. It is 2008, you know. So ML and AI have been there for a long time. Don't think that this is a new technology. It's not. It's been there for a long time. We started using it now itself. Okay. You go through this ALS class. I mean, you may not understand the whole thing, but you will understand the gist of what is happening. That is more important. So then you will know when to put the iterations, how many iterations you have to put, what is the reg param. See, this is called the lambda regularization parameter. What this is doing is it is making all the integers between 0 and 1. That's what is regularization parameter is going to do. So for example, your user ID is some 10,000 whatever, right? So your user ID could be your user ID starts with 0 and it's like whatever. See 15,000 whatever, right? So in that kind of scenario, you don't want to have, so for example, if you are trying to do a plot that is draw a chart, you don't want to say this particular value is going to go off the charts. Your X and Y axis, this is going to go off the charts, whereas 99 and 1 will be within the same. So if you look into these two, they are also hugely varying. So if you want to do X, Y, and then have all these parameters being mapped in one particular chart, then it won't be possible. So therefore, what happens is we are regularizing the whole thing with a 0.01 lambda, so that it becomes 0 between 0 and 1. The values, all these values will be between 0 and 1 with respect to their columns. Then it is easy to chart it. So therefore, you have this regularization parameter. Let me show you where it is. The other easier way is Control V and go through this. So there is a lot of documentation that is there. Go through that documentation and has max iteration with, has max with prediction column. All those things are there. Go through each one of them, and then you will find that, okay, we have what they are used for, kind of. So Notepad, I feel, is much easier because you can see where all it is there. It will give you some index-based searching. So when it is computing the factors, these are all the regularization context, and this is a private. So where is this compute factors being called? It is called in checkpoint while it is being in checkpointed, and while calculating the user factors and item factors. So users items are must, and the rating. User item ratings, these are only three things that ALS, alternate least squares, is going to do. You have set of user, you have set of items, you're ranking them, and then you're finding out what the prediction is. So going back to our the thing, we are splitting it across each one of them. So let me go to here in the interest of time. Okay. Okay. So you see, this is the show here. No? What all the ratings have is this guy. Movie ID, rating, timestamp, and this is the user ID. So you're setting the user column as this user ID. So you could have any kind of columns here. You can name these columns anything. You have to just give that particular thing. Therefore, we need a data set because it can be identified by these column IDs. So this column ID and this column ID are same. And you fit this in here. You are fitting the model in here. Till now, you are creating the ALS. This is the algorithm. It's not the model yet. And then once you fit the training data, you will get the model. This is what we are going to work against, the model. So once we have the model, we are going, transform is basically taking the data set, putting it into model, and then you have this hypothesis. What is hypothesis test? Hypothesis is basically whatever training you have fit, it will come into the model. It is coming with its own prediction. Then what you are doing is you are giving the test to see where the prediction is with respect to the hypothesis we have. So I'll come to this drop later. Okay, you're fitting the training model and hypothesis transform. So now you see, now let's go back to our stages and see how the stages are going to be there. Okay. No, not this one. You now see how many jobs have been done. Okay. what are all the jobs, how the tasks have been. Why we need this is because in multi-threading and multiprocessing, there will be thread starvation happening. So we can easily identify, okay, how much is the thread starvation happening? How much have been the data that's working fast or not? So what are all the stages that are there? And what are the executors? So you have RDDs, you have the drivers. You see the driver executor is just doing nothing. It's just handing over this to the master. And then here you can see how many dead threads are there. That can be, the Spark will revive them by themselves. How many cores have been used? What are the completed tasks? And so this one will tell you what are all the jobs that are there, how the jobs have been accomplished. So this is more like, okay, first it started with this job, CSV, and then collect, and then this. So these are all the stages. These are all the steps that it has executed parallelly. All these steps are executed parallelly. And how much is the storage? What are the stages? What are the jobs? Event timelines. So these are all the completed jobs. This is total uptime that we are having, and how many have been added, how many have been, what is this removed? Removed means if a particular thread is hanging and it has failed, so it will be removed and it will be another thread will be restarted. So the driver is executed and all other things are started. So this gives a very good timeline and tells us where our, for example, 241 we started our driver, and then around 304 the executions have been done. 240 we started our driver, and we are at 304 and it is done. It is getting executed. What is the duration that's happening? We are at 307. So last 3 minutes we have not done anything because we are describing what it is happening. So you have the model is fit with this, and I'll go to the show. Okay, so let's do this. Okay, and this guy, we have put the breakpoint here. So what it is going to do is it will create this hypothesis, and then it will show what the hypothesis is. Okay, then you should see here the changes happening. This is the job that's being performed right now. These are all the stages, stage 63 and all those.
Prakash garu, we are at time andi 1 hour.
Okay, it will take another 2 minutes and I'm done.
Yeah, sure.
So this is where it is showing. So see this prediction. Okay, NAN is there. NAN, there is one, what do you call, strategy where whatever you don't find in the, so this, why is this showing NAN is because the data in the test is not there with respect to the movie. So you have some movie and item which has not been rated before in our training model, but it has come into the test model. So therefore it is saying, I don't know what to do. I'm just saying NAN. For that particular thing, what we do is we just do a drop of the particular columns which are not there. So this one, set cold start strategy. There are two kinds of strategy. One is the default one, which gives out nan. The other one is, if I don't have the particular rating in my training model, I'm going to skip it. So here we are setting the model as drop, and now we will run the runtime for this one. Now you would see what the actual predictions will show. It should not show NaN. Okay. These are test predictions. These are our test cases. Now, assuming we'll have production data that is not part of any test. You see, there is no predict NaN here. So that is what the cold start strategy of drop does. It removes the data which doesn't have the rankings in place. And then this is the root mean square hypothesis. What regression evaluator, what it is evaluating a particular value against what the actual value is. So if the value is a little bit closer to the actual value, it will give 0. If the value is a little bit more, then it will amplify that value, saying that, hey, this is too big. So root mean square is a Euclidean principle. It will be good if you guys just look into that one. And these are all the recommendations. Okay, so let's run it now. Okay, so that we can go through this. I'll put this in the GitHub and share it across. Suspended at breakpoint. Where is the breakpoint? Oh, this guy. I'll just run it. Okay, I'm not putting any more breakpoints. You will see root mean square error is almost negligible. NaN. We are our results are very close to our hypothesis. So these are all the stages where we are generating the top 10 movie recommendations. So you see here, the user IDs are not part of our training model. They are saying that, okay, these are all the top movie recommendations that you have. Now we can go into each one of them and see how the movie recommendations are. You can go to each one of them and see what for each user, different users, it is giving different recommendations. And this is the movie ID, and these are all the recommendations that top 10 movies is this. Top 10 movies for this particular user ID is based on, so we in our what is this algorithm? This algorithm is saying this particular user ID who has some preferences will look at the same thing as 93, and you should look at movie 1. Okay, these are all the recommendations that are there. So take a look into this and try to have more output into this. Or what you could do, the other thing we could do is basically save this particular model also. User recs dot save user recs dot collect and collect as list. Log.info. Recommendation equals to log.info and so let me just run this directly and you will see. Hopefully I didn't confuse you all more than necessary.
Well, I think it will be more clear if we start running it on our local.
Ah.
Anyway, you gave a sufficient information for us to ponder about. Thank you, Prakash.
Sure. Ravi, Anupama, others.
No, Anupama, I think she dropped off. We have got one more, Sandeep.
Oh, okay.
Yeah, she was there like till 10 minutes before.
Now we are anyhow wrapping.
Yeah, we are at the wrapping up, right? So we are good. I think next week we should be able to run this on our local. And
Yeah,
then
this is the thing. You see, this is the user ID, and these are all the recommendations. Say 49 movie ID, 90 movie ID, 68, 94, 55, 70. All these movie recommendations he has been given.
correct, yeah.
Top 10.
Mhm.
So higher the rank, higher the probability for them to see. So why if only 2? Why not 4? Because this guy may have seen all the things that others have also seen. So therefore, those things where the ranking is not there, or least those things you can see. That is the kind of inferences we can give. So this guy may have seen every other movie that similar user has seen. So therefore, everything is like between 0 and 1. And if you see this guy, 4, right? He has not seen a similar movie, a similar user movie that others have seen. So this is a movie ID, this is a recommendation that's given to him or her.
Oh.
Okay, so
Yeah.
all right, let me stop it here. So this I'll put it is there in GitHub. It will be there in GitHub. Let me just give the data.
Yeah, share us the link on GitHub and we will install it, right? We will run it on our local.
Let me see. Commit.
Okay, I need to go out, Prakash Garu.
Yeah.
Catch you again next week, okay?
Okay. All right, let me stop this and happy weekend, everybody.
Yeah. Thank you.
How do I stop?